In a special way, I welcome you to the part 2 of the bearing and distances. Today promises to be a special day as we move into demystifying the topic bearing and distances. Drbolarinwa is still my name. Teaching is my calling. Today we shall start by introducing ourselves to what is called the sine and cosine rule. From the previous class, we treated how we can convert all these textual or written questions into shapes, either triangle or quadrilateral. Having done that, this class we are going to move into how we can find the distances between a point to another point, or we find the bearing of a point from another point. But before we move into that, there is something we need to learn, which is the sine and cosine rule. Because this theorem, this idea is what we are going to use to identify the distances between a point to another point. Equally, that is what we are going to make use of in finding the bearing of a point from another point. Now, let's see what we have next. Of course, we start with the sine rule. The sine rule is simply stated here. A all over sine A equal to B all over sine B, and finally equal to C all over sine C. This implies that whatever the opposite side to the angle is all over the sine A is still the same thing as B all over sine B, and finally C all over sine C. How do we now implement this? We implement this by picking any available 2. We are not going to use the 3 together. By the time we see a question now, we are going to see how these are applicable in solving our questions from bearing and distances. That is after the right or the correct triangle has been generated. Now, working on this, we will ensure that the side and the angle of at least 3 are found. What am I trying to say here? Let's say we have a triangle like this. If this is angle A, angle B, and angle C, from our knowledge from trigonometrical ratio, this opposite side to this angle A will end up to be A. We have this one to be small letter C and this to be small letter B. We can assume that maybe the value here, the angle B, is 42 degrees, an assumed value. And at the same time, maybe the A here is given to be 3 centimeters. Perhaps we are also given this B to be something like 4 centimeters. In this case, if you are asked to find the angle A, we can simply use A all over sine A equal to B, the small letter B, which is 4, all over sine 42. In that case, the 4 entities we are using, we only have one point that is unknown. So in that case, we can easily identify what the angle A is. We cannot find C in this case without first finding the angle A, because if you decide to use B, which is 4, all over sine B, which is sine 42. I'm trying to say, okay, let me start with B all over sine B equals to A all over sine A. Like I said earlier, I said this will work because the B is 4 centimeters all over sine 42, which is B, 42 degrees, equal to A, the small letter A, which is 3. We have 3 here, all over sine angle A. In this case, the only missing point here is sine A. By the time we work this out, we are going to get what the angle A is. Now, let's try to assume that someone intends to work on finding either the small c or angle C without first finding A. What will happen here? Maybe because the B has been given to us, the side and also the angle. Of course, B is going to be involved. So let's see, this is another situation where B all over sine B equals to C all over sine angle C. For B, we have 4 and sine angle B, which is 42 degrees, equals to C, not known, angle C, also not known. Here we are going to end up in a deadlock because both the C and angle C are unknown. But here is a way you can find your C. That is after you have found the angle A. So we just assume that if angle A is gotten to be maybe 50, so we can use the experience of sum of angle in the triangle to give us angle C. Meaning this plus whatever we've gotten for A, we remove the value from 180 degrees, it gives us our angle C. Easy. Perhaps the question was not stated like that. Maybe the question has given us the angle C and assume value. Let's just assume that maybe the angle C was given to us to be 57 degrees. This, at this point, we can find the side C because C all over sine C equals to, we now click on B because we cannot use A in this situation because angle A is unknown, but the side A is known. But we cannot use that because we cannot make use of 2 missing variables. But let's just assume someone has made that mistake. Let's see what will happen. Maybe A all over sine A. What happens? We have C, which is what we are trying to find, all over sine 57 equals to A, which is 3. We have 3 all over sine angle A, which is unknown. In this case, we have unknown here, unknown here. There is no way we will proceed further. We end up in a deadlock. But like I said earlier, this method is not going to work. Now let's see what will happen with C all over sine C equals to B all over sine B. B all over sine B. Of course, C, we are looking for that. All over sine the C, which is 57 degrees, equals to B, which was given to us as 4, all over sine 42. Here we have 57, 42, 4, but only C to be unknown. So this will work. So it depends on the kind of triangle you've generated from the question given for bearing and distances that will determine the kind of formula you are going to apply from the sine rule. So above all, the formula for sine rule is A all over sine A equals to B all over sine B equals to C all over sine C. It is now to us to identify the option we are going to pick from the 3 given values. Of course, let's get this done. We have 3 questions here under the sine rule application. In a triangle ABC, like there is a triangle ABC, that A, the capital letter implies capital letter, the capital letter implies angle A is 29 degrees, angle B is 36 degrees, the small b, the opposite side is 15.8 centimeters. Now we have to find the side A. Now let's get our triangle. So we have the solution. 1. The angle A is 29. So you can just draw it whatever way you prefer. Let's say I have the A here. To be 29 degrees. Equally, the B The B is 36 degrees. So I have 36 degrees here. Definitely we have the C here. I'm following what is given to us. The small b is 15.8. The b, so definitely this, the small b is 15.8. 15.8 centimeters. And we are asked to find the small a. We have to find the small a. How do you even identify if sine or cosine rule is what you are going to use? Because we are still on sine rule. You see, for sine rule, when the angle and the opposite side is given, then either the side or angle is given, you can apply the sine rule. Now for this, b all over sine b is equal to a all over sine a. Perfect. But you cannot say c all over sine c. Moreover, the question did not even state to find angle c or the side c. So we proceed by having anyone can come first. We know that we are applying the b and also the a. So you can choose to start with a all over sine a equal to b all over sine b, or b all over sine b equals to a all over sine a. The two is fine. So I proceed with a all over sine a equals to b all over sine b. Now the a is exactly what I'm looking for, all over sine 29 degrees equals to the b, which is 15.8 centimeter, of course, all over the sine b, which is sine 36 degrees. Wow, I need to get this. So we have the sine 29, a all over sine 29, sine 29, to give us 0.4848 equals to 15.8 all over sine 36, sine 36, to give us 0.5877. Then we cross multiply in order to identify what a will be. So by the time we do that, we have 0.58778. We cross multiply equals to 15.8 multiplied by 0.4848. I want to go for that one time. Or let me write it. 15.8 multiplied by 0.4848. 0.45878 will give us the multiplication of this, which is 15.8 multiplied by 0.4848. Then we have 7.6598. So making a subject of the formula will result to having a equals to 7.6598 divided by 0.5877, and that will give us 13.033. This is what we shall have for this in centimeter, depending on how they want us to leave our answer as. But if you are to leave it as two significant figures, it's going to end up to be 13 centimeters. So I'll finish it to be 13 centimeters in two significant figures. Easy. That's what side A will give us. Having done that, on to the second one, we have a triangle that we have to find the angle A and C. For this triangle ABC, where the small b is 14.35 centimeters, A A is 7.82 centimeters and the angle B is given to be 115.6 degrees. Now we proceed by placing the B wherever we prefer. Let's say this is angle B to be 115.6 degrees. And we have to find angle A and angle C. The information is given to us that A is 7.82. The small a, this is the opposite side to it. We have 7.82 centimeters. I think that's what they're giving us here. And we have to find the angle A and angle C. I think there is more. We have the side B, which is 14.35 centimeters. The side B is 14.35 centimeters. Now it is clear. We have to find angle A and angle C. So by thinking this clearly, of course, the B has angle and it equally has the side. So this is going to work by implementing the B all over sine B as the two options are available. Now let's pick on the second one. Picking on the C at this point will result to error. How? Because the angle and the side are not given. But we can work with A at this point because the side is given, the angle is missing, it works. So we are going to say A all over sine A. Now let's go to the real business. The B is 14.35 centimeters. I'll put that one at the end of the work. All over side B, which is sine angle B, 115.6 degrees. Then we have A. The A is 7.82. Everything all over sine angle A. This is so important. We now have 14.35 all over the sine 115.6. Sine 115.6. This gives us 0.9018 equals to 7.82 all over sine A. From here, we cross multiply because sine A cannot be found. A is what we are looking for, the angle A. So when you cross multiply here, we are going to have 14.35 sine A equals to multiplication of these two, which I'm going to rush at, 7.82 multiplied by 0.9018. This gives us 7.05207. Now we are looking for A. We divide both sides by the coefficient of sine A, which is 14.35. So sine A is going to be 7.0520. Everything divided by 14.35. 14.35. Then we have sine A to be equals to this divided by this. We have 7.0520 divided by 14.35. This gives us 0.4914. We want to find A. So to get our A, the sign comes here. It becomes sine inverse. So adding it as sine inverse, we have A to be equals to sine inverse of 0.4914. And how do we punch out the sine inverse? By pressing shift sine. For some calculators, second function sine. So I have the shift, then sine 0.4914. So we have angle A to be equal to 29.432.6. Like I said earlier, I want to leave my answers in two significant figures. So this gives me A equals to 29 degrees, because we are looking for angles, not the side. So we have 29 degrees in two significant figures. Easy. Having done that, in order to get the angle C, there is no way we can use the sine rule, because both the side and the angle are unknown. So using it will still result to a deadlock, because if you decide to use the newly found A all over sine A equals to C unknown all over sine C unknown, there is no way out of it. So what we shall use here is to implement the idea of sum of angle in a triangle is 180 degrees. That means from the sum of angle in a triangle, which means angle A plus angle B plus angle C to give us 180 degrees. This implies that our angle A, of course, is not 29. This is an approximated value. I will use the exact value, which is 29.432.6 plus, of course, in degrees, angle B, which is 115.6, 115.6 degrees, plus angle C, exactly what we are looking for, to give us 180 degrees. So addition of the two will give us 29.4326 plus 115.6. The addition of the two will give us 145.0326 degrees. Now plus C to give us 180 degrees. By making C subject of the formula, this comes to the side and the sign will change. So we have the C to be equals to 180 degrees minus this, which is 145.0326 degrees. So by the time you remove this from 180, we have the C to be equals to 34.9674 degrees. This is the exact value, but I've been working it like leaving the answer in two significant figures. So leaving this as two significant figures, when this is the first significant figure, this is the second one. So by the time you round up the next one, it becomes 1. I add it to this, it becomes 35 degrees. Easy. Upon completing this, I'll be leaving the third one for you to work as a task. What is happening here from the triangle XYZ? This implies that it's not always about A all over sine A equals to B all over sine B equals to C all over sine C, depending on the variable given to you. So what do we do here is going to be X all over sine X equals to y all over sine y equals to z all over sine z. So I will leave this one for you to work out what the sine z will be. And if you have not subscribed to this channel, kindly click on the subscribe button, thumb up if you are receiving value for this video, and share with your loved ones. Now the next one is going to be working on cosine rule, because sometimes we have a situation where sine rule will not work. So that is the essence of understanding the sine and cosine rule. So to the next one is going to be cosine rule. Welcome back. Thank you for staying with me. Now we are on the cosine rule. The cosine rule will bring solution to our question in case sine rule does not work while solving a bearing and distances question. Now, we have two situations for cosine rule. When the sides are unknown, or when you are looking for the distance from one point to another point, that is when we say the side unknown. We have a different formula for angle unknown. That is when you are looking for the bearing, the angle at which a point is looking, or we are looking at a point from another point. But let's start with the side unknown. We have the formula already given. That means the small side A square is going to be equal to the two sides, the B square plus the second side, which is the C square, minus 2 multiplied by the B and C multiplied by cos angle A. I want you to check the similarity so that you'll be able to identify or understand the formula, how it goes. The second one is B square equals to the remaining two sides, A square plus C square, upon which minus 2 multiplied by the two sides, which are A and C, which is going to be 2 multiplied by A multiplied by C, then multiplied by cos the angle of the side we are working with. So for the third one, which is C square is going to be equal to the two sides, which are A square plus B square, upon which we are removing 2 multiplied by the remaining two sides, which are A and B, 2 multiplied by A multiplied by B, then everything multiplied by cos the angle of the side we are looking for. Now let me give you some examples on how we can use this formula to find the side of missing angles. We have these examples. Calculate the unknown side for the triangle given. Give the final answer correct to 3 significant figures. The triangle is given here. We have the angle B to be 95, the side A 300 meters, the side C to be 200 meters. So it means we have to find the side B. That is the question given. We have to find the unknown side. We are still working on side unknown. So the unknown side here, which is side B, we are going to implement the formula that has been stated here. Let's have the solution here. Sure. Okay, for the question 1, then we have the B, which is going to be B square equal to the two sides, which are A square plus C square minus 2 multiplied by A multiplied by C. Then we now have cos B. That is how the formula is given here. So we have cos B. So we have the B, which we are looking for to be B square equals to A. The A is 300, which we are going to square, plus C, which is given to be 200. We have 200 square, and minus 2 multiplied by A, which is 300, multiplied by C. The C is 200, everything multiplied by cos B, which is 95 degrees. Cos 95 degrees. You see, one thing about this cosine rule here is giving us the grace to identify whatever we are looking for whenever sine rule fails. Because looking at this, let's assume that you want to solve it using sine rule. You are going to say B all over sine B equals to, is it C, the angle that is missing, all over the side, or C, which is 200, all over sine C, which is unknown. That means two sides will be unknown. Or if we are trying to work the B that we are looking for, all over sine B, all over sine 95, all equals to A 300, all over sine angle A, which is unknown. That means sine rule will not work in this case. That's when we implement the use of the cosine rule. Now let's come back to this. Upon identifying our variables, so we now need to solve them one by one. We have the B squared equals to the 300 raised to power 2. We have 300. This will give us 90,000. We have 90,000. Then plus 200 raised to power 2. 200 raised to the power of 2. That will give us 40,000. Now, minus 2 multiplied by 300 multiplied by 200. So we have 2 multiplied by 200 multiplied by 300. This will result to 120,000 multiplied by cos 95. Cos 95. Cos 95 is giving us minus 0.0871. So 90,000 plus 40,000, that will give us 130,000. Now, to this, don't make mistake where many students fail to apply the 2 minus sign that is given here. And even the cos 95 is a positive value, you will have the minus whatever this multiplied by this will give us. But this is minus 120,000 multiplied by minus 0.0871. So it's going to give us a positive value because minus times minus will give us positive value. So let's see what that will give us. 120,000 multiplied by 0.0871. This will give us 10. This is going to give us 10,452. Many students will have made a mistake by leaving the minus sign here, forgetting that minus multiplied by minus will be plus. So we add the two together. We have b squared equals to 140,452. As we are looking towards finding what the b will be, so we have the b equals to the square root both sides. So this will give us the square root of 140,452. So let's have the square root of this. Square root. So we have the b will be equal to 374.7692. And we have to leave our answers in 3 significant figures. That means the first significant figure, the second one, the third one. I round up this 7, it becomes 1. I add the 1 to 4, it gives me 5. So we have the b will be equal to 375 meters because it's measured in meters in 3 significant figures. Easy. Having done that, let's take the second example. We have to find the missing side from the given information here. This is asking us to generate the triangle by itself. So I'm going to solve this A and leave the B for you to practice from O. Now let's see what this A will give us. We are trying to solve the example 2A. They've given us the angle. You can just draw it in whatever way you want it to be. And B is given to us to be 34.5 degrees. The C, which is the small c, let me call this the C. The small c is given to us to be 2.8 centimeters. And finally, the small a is given to us to be 5.1 centimeters. So we are technically asked to find the side B, this small side B. So getting this B means we are going to use the formula again, which means B squared equals to the two sides, A squared plus C squared minus 2AC, then multiply by cos angle B. The B square is going to be equal to the A square, which is 5.1 square, plus C square, which is 2.8 square, minus 2 multiplied by A, which is 5.1, multiplied by C, which is 2.8. 2.8, then finally multiplied by cos angle 34.5. Okay, let me just try to squeeze this out. Cos 34.5 degrees. Yes, I'm going to need a calculator again. The B square is going to be 5.1 square. 5.1 square. This will be 26.01 plus 2.8 square. 7.84. Now minus 2 times 5.1 times 2.8. 2 multiplied by 5.1 multiplied by 2.8. This will give us 28.56 multiplied by cos 34. This is a positive value this time around. We have it to be 0.8241. Now we add these two together. B squared equals to 33.85 minus, because by the time you multiply these two together, it will still end up to be minus. So we have now we remove this from this. This will give us 10.3137. We want to find the B, so the B is going to be square root of both sides. The square root of 10.3137 will leave us to add them. We have our answers to be 3.211419. And the intention is to leave the answer in 3 significant figures. The first significant figure, the second one, the third one. So looking at this one, it's not up to 5. So everything becomes 0. So that makes B to be equal to 3.21, because this one will result to 0. Easy. Now let's check. Is it in centimeter? Of course, it's in centimeter. So we leave our answer like this. So you have the B to find the missing side. Now for the next one, which is going to be the angle unknown. Having found out to identify the distances between one point to the other point, it is equally important to identify how to find the angles from one point to the other, because we are going to need it whenever we are finding the bearing of one point to the other. So this brings us to the angles unknown under the cosine rule, where we have the three angles from angle A, B, and C, of course. To know the angle A, we have the formula to be cos A equals to the two sides, that is the B and the C, of which we are going to square the two, the B square plus C square minus A square, everything all over 2BC. So it is important for you learners to identify or understand what these formulas are without mixing them up. We have for angle B2, which is cos B, equals to C square plus A square minus B square, everything all over 2AC. And finally for the C, cos C is equals to the two sides, which is equals to A square plus B square, then minus the angle itself, which is angle C, which is going to be C square, everything divided by 2 times the two sides A and B, as we have the formula here. Now the next one is going to be solving a question that has to do with identifying or finding the angles in the triangle using the cosine rule. Now we have this question. To find the angles in the triangle ABC, give the final answers to the nearest 0.1. So we are meant to find the angle A, angle B, and angle C. So let's assume that the side given here, they are in centimeters. We have them in centimeters. So we are meant to find the angles in A, in C, and also in B. So we are free to start from any point. And looking at this, there is no way we can use sine rule, because sine rule will result to A all over sine A equals to B all over sine B equals to C all over sine C. But how do we implement this without having, ending up in a deadlock? Because if you pick A all over sine A is not known, and you connect it with a B all over sine B, B is also unknown. So we need to apply the cosine rule in this case. So let's start from A, the solution. So using A, the formula is, or starting from A, the formula is cos A is equal to the two, this is from cos A. So you pick on the B and also the C. Let me write the formula again. So we have B squared plus C squared minus the opposite side to the A, which is 5, of course. But let me deliberately write the formula again. A squared, everything all over 2BC. 2BC. Now let's substitute this value into this. We are looking for A, of course. So we have B. The B is 2. So we have the 2 raised to power 2. Then C. The C is 4. We have 4 raised to the power of 2 minus A, which is 5. We have 5 raised to power 2. Everything divided by 2 multiplied by B. B is 2. Then multiply by C. C is 4. So moving on from here, we have cos A to be equal to 2 raised to power 2. That will give us 4 plus 4 raised to power 2. That is going to be 16. Then minus 5 raised to power 2. It will give us 25. Everything divided by 2 times 2, 4. 4 times 4, we have 16. So cos A is going to give us 4 multiplied 4 plus 16. We have 20 minus 25. Everything all over 16. So cos A is going to give us minus 5 all over 16. So we have cos A to be equal to minus Definitely 0 point something. So let me verify from here. I'll be having 5 divided by 16. That will give us minus 0.3125. So for us to get the A, the cos will move to the other side and it will become cos inverse of minus 0.3125. So from the calculator, A will result to 108.2099, and we are meant to leave our answer to the nearest 0.1, which means to 1 decimal place. So leaving this one to nearest 0.1 means it's going to be this decimal point. So we have the first decimal here. So rounding off this one is 0. So everything becomes not significant. So we have 108.2 degrees. That is the angle A. Easy. Now for the second one, which is B, cos B is going to be, we already have the formula, so there is no point rewriting it. It's already well stated, c squared plus a squared. So you can choose to start with a squared or c squared. Whatever it is, they are being added together. So let me decide to start from a squared. So from cos B, we have a squared. That will give us 5 raised to the power of 2 plus c squared, which is 4. 4 raised to the power of 2. This is 5. Then minus b squared. The b is 2. So we have minus 2 raised to the power of 2. Everything divided by 2 multiplied by a. The a is 5. Then multiplied by c. The c is 4. Now we move on. Cos b is going to be 5 raised to the power 2. We have 25. Then plus 4 raised to the power 2 will give us 16 minus 4. Everything divided by 2 times 5, we have 10. Then 10 times 4, we have 40. So we can add the 2 together here. Cos B will result to addition of these 2 will leave us with 41. Then minus 4, everything all over 40. We see how the cos B. So for the cos B here, we have 41 minus 4. This will give us 37. We have 37 all over 40. So cos B is going to be equal to 0. Check. 37 divided by 40. This will give us 0.925. So B will result to cos inverse of 0.925. So by the time we punch the calculator, we'll be having B to be equal to 22.3316. So leaving our answer to the nearest 1 decimal place will give us 22.3 degrees. Easy. Now for the C, having found the A and the B, we can decide to use sum of angle in a triangle to get the C, or still stick with the formula of cosine rule, which is a squared plus b squared minus c squared, everything all over 2ab. So let me start with using sum of angle in a triangle. So that's going to result to, from sum of angles in a triangle, that's going to result to C being 180 minus addition of the two angles A and B. That is going to be 108.2 plus 22.3. So the C is going to be 180 minus 108.2 plus 22.3. 130.5. So the C is going to be 180 minus 130.5. The C is going to end up to be 49.5 degrees. Having journeyed with me from the part 1 to this point, I'm not expecting you to be scared of this question, though it looks a little bit long, but of course we are here to crack this bearing and distances together. Having passed through the cosine rule and the sine rule, which we are going to use as tools in solving questions for bearing and distances. So let's see how we crack this together. A ship sails across the distance of 5 kilometers. That's the distance. Then from point A to where? To a particular place on this bearing 60 degrees. So it's like they are giving us a true bearing. From what we had in the previous video, we had that from here to here is 90. So definitely 60 will be around here. So it means from point A, or no, not even from point A. Yes, it's from point A. From point A, the ship sails 5 kilometers on this bearing 60. So we can say we have our point A here, and it sailed on the bearing of 60. Because coming down here will result to 90. So it went to this direction, and this is 60 degrees. And the distance is given to be 5 kilometers. So when we have the 5 kilometers here, so this is the new position of the ship. Then it sails another 8 kilometers. It went to another place across the distance of 8 kilometers. Maybe it went this way, this way, this way, this way, or this way. We don't know until we have the bearing. So we now have on a bearing of 120 degrees. That means from north, that's where we pick it from. So we cut across to this place, 90. 120 should be slightly beyond 90 because this is 180. So definitely we have 120 around here. And the distance is 8 kilometers. So this one, we went this direction. We can just allow it to be a little bit longer than this. Not like we are having a true measurement, but we are just trying to make it a little bit realistic because this is 8 kilometers and the bearing is 120 degrees. Find the distance between the starting point here and the final position. The ship is now around here. So they said the ship started from A. It was not stated that it went to B and is now at C. So we can now assume that, well, this is the new position, the second position, and it finally stops at this point C. Then we are asked to find the distance between the starting point here and the final position. So we are looking for the distances from here down to this place. That's what we are looking for. We are looking for the small b because they ask us to find the distance from the starting point where the ship started. The starting point to the final position. The ship is now here. So technically, we are looking for the small b. Now, when we want to work this out, we need to learn how to identify the angles where possible. From alternate angles, as this place is 60 degrees, definitely this place is also going to be 60 degrees. After that, we have from here to be 120. If it goes from here down to this place, it becomes 180 degrees. Definitely there is something here. I'm giving you 3 seconds to think what this place will be. If from here to here is 180, but from here to here is 120, what will this place be? Of course, it's going to be 60 degrees because it's going to be 180 minus 120. So this place is going to be 60 degrees. Now we have the angle. The angle B in total is going to be 60 plus 60, which will give us 120 degrees. In case someone has missed something here, this is 60 degrees. From alternate angle, we have our 60 degrees here. And from coming from here to here to become 120, if it comes down, it becomes 180. So definitely the remaining part is 60. So addition of the two 60s will give us 120 degrees. Now we can think of what we are going to use. If we decide to use sine rule, you may not be able to get the answer, but let's try to rewrite the triangle now. We have our triangle to be like this. This is point B, point A, and point C. If this is 120 degrees, this is 5 kilometers, and this is 8 kilometers. I want to find B because it's the distance from the starting point to the final point. If you use sine rule here, it's going to be B all over sine B equal to A all over sine A. A is unknown. If you decide to use it with C, angle C is also unknown. So what we are using here should be cosine rule. Here we are looking for what? We are looking for the side unknown, not angle unknown. So we go back to the formula of side unknown, which is B squared equal to A squared plus C squared minus 2AC, then multiply by cos the angle itself, cos B. Now we are looking for B squared, of course. B squared is going to be A squared. A squared plus C squared, which is 5 squared minus 2 multiplied by A, which is 8, multiplied by C, which is 5, then multiplied by cos of 120 degrees. B squared is going to give us, A squared is going to be 64. 8 times 8 is 64. We have 5 times 5 to be 25. Then 2 times 8. In fact, 8 times 5, 40. Then 40 times 2, we have 80. Then multiply by cos 120. I don't need to write cos 120 again. Let me just punch this out. Cos 120. Cos 120 should be minus 0.5. Minus 0.5. So the B square is going to give us 64 plus 25. That's going to give us 89 minus, it's not even going to be minus because we have minus 80 times minus 0.5. Minus times minus will give us plus. 80 multiplied by 0.5. You may punch your calculator, but 0.5 is half, so technically it's going to end up to be 40. So the B square is going to be equal to 89 plus 40. That's going to be 129. 9. And the B is going to be the square root of 129. So I need to punch calculator at this point. The square root of 129 will give us 11.3578. We are meant to leave the answer to 1 decimal place. So leaving this one to 1 decimal place, this 5 becomes 1. We add it to this 3. The P becomes 11.4 kilometers. Easy. It's been a very long journey, but it's not over yet. I'm leaving you with these 2 tasks. We have the first one and the second one here. Of course, you don't need to be overwhelmed by this. All you need to do is to apply what you have learned across the journey so far. So we have the question 1 and 2. I want you to practice from home. Try to identify what the triangle is going to look like. Then find the distances and equally find the bearing from C from A. Same thing applies here. You are meant to find the distance between the 2 ships that left the same port at the same time, of which one traveled 70 kilometers, the other one went for 50 kilometers. The first one went on the bearing of 45 degrees, while the second one went on the bearing of 135 degrees. So make attempt on this. In the next video, which will be the part 3 of the bearing and distances, then we shall focus on questions like this and solve this question which you have practiced already. Then from there, we shall now proceed into more complex questions. If you have stayed with me till this moment, it's an indication that you are truly enjoying this video piece. And if you are new on this channel, kindly click on the subscription button and please share with your loved ones and thumb up if you have received value for this video. Till when else I see you, I say do have a lovely time.